What's up, intermediate algebra? Mr. Smith is here. I'm in my little office upstairs. It's starting to become an office. I got my LED lights set up, so that's a step. But long time no see. When I'm making this Monday, we haven't even had class yet. I had a sub for you guys on Thursday. I hope it went well. We'll talk about it shortly. Off-campus learning day, we did some Khan Academy, and then I was on guys camp out, so I am just back to civilization. I slept in a tent the last 72 hours, so I'm tired. But I'm ready to get after it. And this is like the calm before the storm. We have this week, and then we have homecoming coming up, which is going to be awesome. So I really have two things that I want to show you today. We're going to talk about standard form and how to tackle that. And then we're going to talk about slope in the real world and what it looks like to actually apply it and look at some real world word problems, which is kind of why we want to learn all this in the first place. So first thing, we learned about y equals mx plus b. Okay, that's slope-intercept form. And an example of that would be y equals, say, 2x minus 5. The 2 is the slope. The 5, the negative 5 that is your y-intercept. So slope and y-intercept. Then we had point slope. Y minus a y value equals your slope times x minus an x value. An example of that one might be y minus 4 equals 1/2 x plus 2. That might be an example of that one. So we have slope-intercept form, slope-intercept, point slope, and then we have a third form, which is just called standard form. And I'm going to show you how to deal with it, because I think it does two things that can be helpful. Standard form looks like this. Something x plus something y equals something. And it's better shown like this. Let's just say 2x plus 4y equals 8. That is a linear equation because x and y are just to the first power, just like they are in the other ones. But notice how it's not in an order that we really have used before. It's not in slope-intercept form, y equals mx plus b. It's not like that. It's not in point slope form. It's in standard form. So the first thing that we need to be able to do really quickly and really efficiently is we need to be able to take something that's in slope-intercept, that is in standard form like this, and switch it around and rearrange it to where it's in slope-intercept form. So remember, slope-intercept form starts with y equals. So if we want to get this into slope-intercept form, we're going to do what we did in chapter 1, where we are going to solve for y. We're going to do whatever it takes to get the y by itself. So I want that y by itself, so I'm going to move the 2x over to the right side first. So I'm going to use subtract. So that's gone, and we have 4y equals 8 minus 2x. Let's put the slope first, so minus 2x plus 8. Notice what I did there. I could have written 8 minus 2x, and it would be the same. But remember, for us, we like to have that mx right there at the front, y equals mx plus b. You can see we're one step away from converting this to slope-intercept form. The last thing we would do is we need to divide by 4. We divide everything by 4 to keep the scale balanced. So we have y equals negative 2 divided by 4 is negative 1/2. And then 8 divided by 4 is 2. So this right here, y equals negative 1/2 x plus 2, is the same line as our original line was 2x plus 4y equals 8. Those are the exact same lines. Don't believe me? Let's prove it. Desmos.com, graphing calculator, y equals 1/2 x plus 2. There's that one. And what was standard form? Oh, negative 1/2 x plus 2. Standard form was 2x plus 4y equals 8. 2x plus 4y equals 8. Booyah. Let me turn that one off. There's the first one. There's the second one. First one, second one. What do you notice? They're the exact same line. Okay, this is in standard form. Notice how it's x and y number. This is in slope-intercept form. Y equals mx plus b. This one is way easier to graph. Y equals mx plus b is way easier to graph. But let me actually show you the other thing that standard form is good at. So standard form, the first thing you need to be able to do, pause the video, you have to be able to convert from standard form to slope-intercept. Okay, got to be able to do that. You move the x, you move the x term, you divide by y. Move the x term, divide by y. Move the x term, divide by y. Okay? But here's the other thing that is really nice for standard form is you can find your x and y intercepts really quickly. What are x and y intercepts? It's where the line crosses the x-axis. So I think it was somewhere over here. And it's where the line crosses the y-axis. It was somewhere up here. But let's actually find those. The way you do it, this is pretty rad, is if you want to find the y-intercept, so if you want to find the y-intercept, you plug a 0 into the x spot. And if you want to find the x-intercept, you plug a 0 into the y spot. Now, why is that? Why would, if you wanted to find the y value, the y-intercept, would you plug a 0 into the x? Here's why. What's this point? It's the point 0, 2. What's this point? That's the point 0, 4. What's this point? That's the point 0, 7. What do you notice for all of these y-intercepts? The x is 0. Okay, so then let's do it the other way. What if you were looking for the x-intercept? What's this point? That's the point 1, 0. What's this point? That's the point 3, 0. What's this point? That's the point negative 2, 0. What do you notice about our x-intercepts? They are all have zeros in for the y value. So knowing that by plugging in a 0, we can go and find the x and y intercepts is actually a great way to graph a line. Because all you need to graph a line is 2 points. So if I knew that my x-intercept was 3 and my y-intercept was 6, if I knew that, I've got my line. It's kind of awesome. We can use the intercepts to graph the line. So let's do it. Let's find the y-intercept. We plug a 0 in for the x. So it's 2 times 0 plus 4y equals 8. 2 times 0 is 0. So it's literally just 4y is equal to 8. Y equals 2. Look how easy that was. The y-intercept is 2. So boom, we put that down. The point 0, 2 is what we just found. Now let's do it for the x. 2x plus 4 times y. We put a 0 in for the y this time. 2x. 4 times 0 goes away. So it's just 2x equals 8, x equals 4. Like that was so easy to find our y-intercept and our x-intercept. And when we have them both, we can then connect the line. Because all you need for a line are 2 points. And we found the point 0, 2 and the point 4, 0. Pause the video there. Rewatch that. That is huge. Like that could literally save you with linear equations if you feel comfortable with finding your intercepts by plugging in a 0 for the x to find the y-intercept and a 0 for the y to find the x-intercept. That can be huge. Okay? So finding intercepts. So what is standard form useful for? You got to be able to do this. You got to be able to take something in standard form, like 2x plus 4y equals 8, and you've got to be able to convert it to y equals mx plus b. That's the first thing. And then the second thing is we've got to be able to see standard form, and think, hey, I can find the x and y-intercept really quickly by plugging in zeros and solving. Okay, so that was great. I'm glad I went off on that tangent. So then the last thing is this. Let's talk word problems. I'm just gonna make up a word problem. All of us have cell phones. We're addicted to our cell phones. So let's create a linear equation for how much our cell phone bill costs. Okay, so let's just make this up. Cell phone bill. Okay, and I'm going to ask you this question tomorrow, and if you watch this video, you will have the answer. This is how I'm going to know whether or not you watch the video. What phone company has my dad worked for 30 years? What phone company has my dad worked for 30 years? Okay, I'm going to tell you that at the end of the video. I got 3 minutes. So, cell phone bill. Let's do this. Let's say that it costs 60 cents for every gigabyte of data that you use. I'm just making these numbers up, but we could probably find this online. Let's say that no matter what, there's always a $25 fee. Like every month you pay $25 no matter what, even if you don't use the phone. So then how would we create a linear equation that models the cost of your cell phone bill depending on how much data you use? Okay, how would we model an equation for the cost? What if we did this? We got to find our two variables. What is our x variable? What is our y variable? The y variable is the cost. But which one of these determines the cost? Look in this. Which one of those is going to cause our cell phone bill to change at a constant rate? That is how much data you use. So the x variable is gigabytes of data. So if the y is the cost and the x is the gigabytes of data, then we could say, here's our answer, that the cost is equal to 60 cents. So 0.60x plus $25. Okay, hold on a second. We just did something cool there. Let's look at this equation. This is our slope, 0.6. Let's look at why it's our slope. It's because that's what's changing. The amount of data usage that you have is what's changing. So 60 cents per gig, that's what the x is. So this is our slope. Our slope is 0.6. It is changing. Your bill's going up 60 cents for every gigabyte of data. So if you spent 20 gigs, you'd put a 20 right there. And you could find how much your cell phone bill costs, because you would just use your calculator from there. Okay, so making an equation, the reason we do it is because then we can use it to answer any question that we need to find. Okay, now let's look at this 25. That is our Y-intercept. That is our starting cost. No matter what, you are going to pay $25. That's why there's no variable there. That's a constant. You pay $25 every month. But then depending on how much data you use, your bill is either going to go up or stay at $25. Okay, so here are some questions that I might ask you. What does the slope mean in the context of this problem? You would tell me that the slope shows that for every gigabyte of data that we use, our cost increases by 60 cents. Okay? And then the Y-intercept, what does that mean? That means that there's always a flat fee of $25. You pay $25 no matter what. Okay? What if I asked you this, and this is where we'll close the video. Your cell phone bill cost $32. How many gigabytes of data did you use? Ooh. Well, if 32 is the cost, we can plug it right there, and we should be able to work backwards. Minus 25. That's 7 equals 0.6x. We divide both sides by 0.6. And x, what do we get? Let me just use my phone real quick. 7 divided by 0.6. We used about 11.6 gigs of data. Okay, we can use linear equations to solve real-world problems, and we're going to do that in class today. So, what company did my dad work for 30 years? There's the answer. If you watched this video, I'll know, because you will know that my dad, Bobby Smith, has worked at AT&T for his entire career and worked in this building. It's called the Batman Building in Nashville. See y'all tomorrow.